Good day everyone, we are the Group 6 to present our project entitled Molicum, Molality, and Molarity Calculator.
The programming language used for this program is Python. We use comparison and arithmetic operators, conditional statements such as if, else, and elif, and a while loop. User-defined functions were also used for this program. The comparison operators were used to compare values, often in conditional statements to decide the program's flow, while the arithmetic operators are used for performing basic arithmetic operations. For example, division is used to calculate concentrations in the functions like calcmolarity and calcmolality. The conditional statements were used to direct the program's flow based on certain conditions. These statements execute different blocks of code depending on the truth value of the conditions. For example, in functions like calcmolarity and calcmolality, conditional statements check the unit of measurement and apply appropriate conversions. The while loops are used to repeatedly prompt the user for input until a valid response is received, ensuring the program only proceeds with correct data. It can also keep the interactive menu running, allowing users to perform multiple calculations without restarting the program. For the calcmolarity function, it calculates the molarity of a solution. It takes the number of moles and the volume of the solution in a specified unit. The calcmolar mole function calculates the number of moles of solute given the molarity and the volume of the solution. It takes the molarity, volume of solution, and the unit of volume. The calcmolality calculates the molality of a solution. It takes the number of moles of the solute and the mass of the solvent in the specified unit. The calcmolal mole calculates the number of moles of solute given the molality and the mass of the solvent. It takes the molality, the mass of the solvent, and the unit of mass. For the calcmolar mass mole, it calculates the number of moles of solute given the mass of solute and its molar mass. It takes the mass of the solute, its molar mass, and the unit of mass. Lastly, the main function. It provides an interactive menu for the user to calculate molarity or molality and related quantities.
So, as the main purpose of this calculator is to be a tool in solving molarity and molality problems, we incorporated features that will make the process of solving said problems easier. So, first, we can calculate molarity problems by entering the molarity calculator. So, let's enter one here for molarity calculator. So, in molarity problems, sometimes the moles of solute or the volume of solution are the ones that is needed to be found, as the molarity formula can be flipped to find other variables in it. So I added a feature that provides an option to also find them. The calculator itself does the flipping of the formula. So let's say that in a molarity problem, we need to find the molarity. So let's enter 1, then enter the moles of solute. So let's say 20. And then enter the volume. And then as you can see, there are other options for other units for volume. This is another feature of the calculator. This is added as sometimes the given unit in problems does not match the required final unit. So in molarity, the volume must be in liters. In this feature, the entered not in liters unit will automatically be converted into liters, as you can see here. So let's say that the volume 200 is in ml. So as you can see here, in the final answer, the given is in moles over liters, or simply just them. So the ml is automatically converted into liters and then was used as a liter in solving the final answer. And then now let us focus on the molality. So let us go back to the main page, and to do that, let's just enter number 4. So now that we are here, let's go to the molality calculator. So number 2. So similarly, as you can see, there are other options to solve for either the moles of solute and mass of solvent, as formulas do the molality formula can also be flipped. So sometimes the problems require the students to find either the moles of solute or the mass of solvent. So now that we are here in the molality calculator, so let's say that we need to find the mass of solvent instead. So let's enter number 3. So as you can see, this is another added feature. So in molality problems, sometimes the moles of solute is not given explicitly. So the students need to find it first by calculating the molar mass, but with the molar mass and the moles of solute. So there is an option here to calculate with them or not. So let's say that in a problem they need to calculate with them. So let's just enter yes here. And then now there is an option to enter the molar mass. So let's say the molar mass is 20 and the mass is 200. So as you can see here, the mass units, there are other options for mass units too, as similar to molarity. The required unit for molality is in kg, but sometimes in problems they are given in units that are not in kg. So let's say it is in grams, and then let's enter the molality. So let's say it's in 0.02, and then there you have it. So it is now in kg. So this unit for mass that is in grams is automatically converted into kg by the system, so that it would be easier for the students to see the final answer. And as you can also see, the moles of solute is also displayed as that could be part of their the solution that they are writing. So there you have it for the molarity and the molality calculator.
In relation to our current program, this project is highly relevant to Bachelor of Science in Chemical Engineering, as it provides students with a practical tool for calculating solution concentration, an essential skill for designing process and conducting experiments. By incorporating Python programming, the project enhances computational skills crucial for modern chemical engineering tasks such as process automation and data analysis. Additionally, it offers an interactive method to deepen the understanding of fundamental concepts like molarity and molality, which are critical in various chemical engineering courses. This integration of technological innovation into the educational experience better prepares students for industry demands. And that is all for our presentation of Molicum, a calculator for molarity and molarity. Thank you.